You know, every single time you use your computer or your phone or even the screen in your car, you're interacting with this silent, invisible ruler. It's a core program that has complete control over everything, every resource, every click, every single keystroke. This is the story of that unseen ruler, the kernel.
I mean, really think about it for a second. You click on an icon, say, to open up your web browser. Seems pretty simple, right? Instantaneous even. But that one little click sets off this incredibly complex chain reaction. Your request travels from the screen deep down into the foundations of your operating system, where it has to get permission from this central authority just to get the resources it needs to run. So, who is this powerful gatekeeper?
Okay, let's break this down. The kernel is the absolute heart of any operating system. It's the very first program that loads when you boot up your device and the very last one to shut down. Now, to make sense of all this, we're going to use an analogy for this whole explainer. Let's imagine your computer is a big, bustling city. All your apps, your browser, your music player, your games, they're the citizens. And the kernel? Well, the kernel is the city's government.
And just like any good government, the kernel has a few absolutely essential jobs to do to keep that city running smoothly and safely. We're talking managing traffic, zoning all the land, and making sure all the public utilities are working. First up, CPU management. So your computer's processor, the CPU, it can really only do one thing at a time. But you've got dozens of programs all wanting to run at once. The kernel steps in and acts like a traffic controller, just expertly juggling the CPU's attention between all these programs. It decides who gets to go, who has to wait, and for exactly how long, making sure no single app can cause a citywide traffic jam.
Next up, you've got memory management. Think of your computer's RAM as all the land in the city. The kernel is basically the zoning board. It carves out a private, protected plot of land, or memory, for each and every application. And this is so important because it stops a buggy program from, say, building on another program's land and causing it to crash. This separation between where the apps live, called user space, and the government's high-security district, or kernel space, is totally fundamental to keeping the whole system stable.
The kernel also has to manage all the city's public utilities. Your hardware, your keyboard, your mouse, your screen, your printer, they're like the power grid and the water supply. All your apps need to use them, but they can't just plug in directly. The kernel manages all these connections through special little programs called device drivers, making sure every citizen gets the power and water they need without having to go mess with the dangerous main lines themselves.
So how does an application actually ask for any of these services? Well, it can't just barge into the government's offices. There's a formal process, and it's called a system call. It's kind of like filling out an official form at City Hall. The application packages up its request, like, hey, I need to write some data to the hard drive, or I need to access the network, and the kernel reviews the form, does all the heavy lifting for the app, and then just hands back the results.
Now, here's where things get really interesting. If the kernel is a government, it turns out there isn't just one way to run the city. For decades, computer scientists have been debating two totally different political philosophies for how to design a kernel, and each one has its own major pros and cons.
On one side, you have the monolithic kernel. Think of this as a super centralized government, where every single service, traffic, zoning, utilities, you name it, operates out of one massive, powerful building. Communication between departments is lightning fast, because hey, everyone's in the same room. But the risk is huge. If one little department has a problem, like a bug in a device driver, it can bring the entire government crashing down. On the other side, you've got the microkernel. Here, the central government is tiny. It does the absolute bare minimum. Everything else is handed off to independent local agencies that run just like regular citizens. It's incredibly stable. If one agency fails, the others just keep on chugging. But things move a lot slower, because every request means sending messages back and forth all across town.
And this was not some quiet, polite academic debate. Oh no, it got heated. It got personal. This famous quote is from a public argument between Andrew Tannenbaum, a big proponent of microkernels, and this young programmer named Linus Torvalds, who had just created a brand new monolithic kernel you may have heard of called Linux. So you have these two extreme political parties, right? One is yelling for total centralization, and the other for radical decentralization. And in politics, and as it turns out, in computer science, when you have two extremes, you often end up with a compromise.
And you can really see the evolution of the idea right here. The first big idea was monolithic. Just cram everything inside the government building for maximum speed. Then came the reaction, the microkernel. Kick almost everything out for maximum safety and stability. And that brings us to the modern solution, the hybrid kernel, which really tries to get the best of both worlds. It keeps the most essential, performance-critical stuff inside the kernel, but it lets other components, like some device drivers, run outside.
So let's see where these different governments actually show up in the real world. Linux is, of course, the most famous example of a monolithic design, although today it's become super modular, which lets it load parts on demand. True microkernels, like QNX, you'll find in systems where stability is everything. We're talking cars, critical medical equipment, stuff that absolutely cannot fail. And the operating systems that most of us use every day, Windows and Apple's Mac OS? Yep, they both use a hybrid kernel, trying to find that perfect balance between performance and stability.
Okay, so we've talked a lot about city governments and competing philosophies and all this technical stuff. But why in the world does any of this actually matter to you when you're just trying to send an email or watch a video?
It matters because the entire experience of using your device, how fast it feels, how often it crashes, is totally shaped by these really deep design decisions. At the end of the day, it all comes down to a balancing act. Every kernel design is a constant trade-off between three competing goals: speed, making your computer run as fast as possible; stability, making it as crash-proof as possible; and security, making it as safe as possible.
And you can see that trade-off right here, plain as day. A monolithic design, like Linux, is all about raw speed. A microkernel design, like QNX, is built from the ground up for stability and security above all else. And the hybrid kernels in Windows and Mac OS, well, they're trying to find that practical sweet spot right in the middle. There's no single best government. It all depends on what kind of city you're trying to build.
Which brings us to one last big thought. Our digital world is not getting any simpler, right? We've got computers now with dozens of cores, billions of tiny devices, all talking to each other. The old ways of running the city, they might not be enough for the future. So the question we're all left with is this: as our digital cities become these massive, sprawling megaregions, what will the next form of government even look like? The debate is far, far from over.